Okay, so we are going to solve this next problem here, 8x squared plus 3 equals 5. And we're going to try to see if we can solve it all three different algebraic methods. So let's go ahead and first see if factoring is a possibility. So first thing when we're factoring, we want to make it equal 0. So first step is we're going to subtract 5 here. Okay, then after it equals 0, we need to look for a GCF. So something that goes into 8 and 2. So since it does have a GCF, we're going to put the 2 in the front of the parentheses. And then 2 times 4 gets us the 8, and we need the x squared, so that these two will multiply to make 8x squared. And then 2 times -1 would get me back the -2 here. Okay, so then after GCF, we ask ourselves how many terms, and there are 2 terms here. So when there's 2 terms, and this is a square and a minus, we look for a difference of squares. So I know that 2x times 2x makes 4x squared, and I know 1 times 1 is 1. So the formula I would use, I'm going to bring down the 2 will not go away. The formula we're going to use is 2x plus 1 and 2x minus 1. That's how we're going to get this -1 right here. Okay, so now that it's completely factored, we can't factor these any further because the exponent is a 1. Then we're going to set each factor that has an x equal to 0. So this 2, we're going to ignore this because if we set it equal to 0, there's no x there. So then we're going to set both of these equal to 0. And then we'll get our 2 solutions this way. So subtract 1 and then divide by 2. So one of the solutions is -1/2. Divide by 2, and we get x equals +1/2. So again, remember the highest exponent was a 2. We can get up to 2 solutions. Okay, so next method that we're going to try is the square root property. So notice over here it says completing the square. So with this problem here, we had to complete the square because it had this b value right here, the b term. Whereas this problem here, you can see it does not have just a single x. It has an x squared. So that's how you know when it would be completing the square would be another option versus this one's going to be the square root property because we don't need to complete the square. We're going to be able to get the square all by itself. So again, what I mean by that and why we're not going to complete the square is because I can get this all alone because it's the only term in the problem with an x. So we can do -3. And then we could divide by 8 so we can get this x squared all by itself. And then 2/8 simplifies to 1/4. And again, why don't we need to complete the square? Because it's already a square. So then we can square root both sides, and when we square root both sides, we need the plus or minus. Now this 2 and this radical here that I put in are going to go away because 2, there's this imaginary index of 2. 2 goes into 2 once. So that goes away. And then this can be split up into the square root of 1 over the square root of 4, and the square root of 1 is 1, and the square root of 4 is 2. So we get the exact same answer that we got here, +1/2 and -1/2. Okay, and then lastly, let's go ahead and try it with the quadratic formula. So the quadratic formula, it has to equal 0. So since we already did that work over here, I'm going to take the 8x squared minus 2 equals 0. So it has to equal 0. And then once it equals 0, you can identify A is the number in front of x squared. B, there is no x term. So B is going to be 0. And C is the one without any variables, so -2. Okay, then we're going to go ahead and plug it into our quadratic formula. Okay, so we have, wherever the zeros are here, -0, that's just saying there's nothing there. So I can just put plus or minus. If you want to put that 0 there because it bothers you, that's fine. And then 0 squared, that's just going to be 0. So I can just not put anything, but if it bothers you, we'll put a 0 there. And then here we're going to enter that in as -4 times +8 times -2, which is +64. Okay, so then here we have 0 plus 64, which is 64. And again, if you want to put the 0 there, that's up to you. And then the square root of 64, what times itself is 64 is 8. So, and then 0 plus 8 is 8, and 0 minus 8 is -8. So that's why the 0 didn't need to be there, because when you add 0 to anything, it doesn't affect anything. So that's why I didn't need that there. So just plus or minus 8 over 16. And then 8 goes into 8 and 16. So we get 1/2, negative and positive 1/2. Okay, so now up to you. What do you think? If this was on your test, which method would you use? If it were me, that's probably the method I would have used. So again, how would I have known that this is probably the most efficient or quickest method? Well, again, when I look at the problem, I don't see a term that has an x. I don't see a 3x or a 5x. The only x term in the problem is the x squared. So when you see that, that's when I would use the square root property, get the x squared alone. And I just want to demonstrate again why solving quadratics, when you're done, you should feel good about your answer. If you take the original problem, and then wherever there's an x, you plug in, we have two answers, so we'd have to check both. I'll show you one of them. If I type in 1/2, and then squared, and then plus 3, if 1/2 is a correct answer, we should get 5. Okay, so then we can do it again and do -1/2. We get 5 again. So then we would walk away knowing, cool, got this one correct.